Good morning, students. In the previous lecture, we have discussed about the CPU scheduler, dispatcher, the concept of multiprogramming, and so on. In today's lecture, we will discuss the first come first served scheduling algorithm. So, this is the simplest scheduling algorithm in the operating system. The process that requires the CPU, it is the CPU is allocated to that process which it requests is first. As you can see in this diagram, that the implementation of first come first served policy can be managed with the help of first in first out queue. As we know the concept of queue, that removal takes place from the head and addition takes place at the tail. So when a process enters the ready queue, its process control block is linked onto the tail of the queue. And when the process is free, if when the CPU is free, then it is allocated to the process at the head of the queue. Means a CPU selects the next process from the head of the queue and a new process is added at the tail of the queue. And the running process is then removed from the queue, means currently running process is removed from the queue. The average waiting time under the first come first served policy is in fact long, and it depends upon the order of arrival of processes. For example, look at this table. We have three processes and we have the burst time of each process. Here burst time is the execution time. For example, P1 executes for 24 units of time, means 24 units of time is the completion time of process P1. Similarly, the burst time of P2 is 3 units and the burst time of P3 is 3 units again. Now, if the processes arrive in the order like P1, first of all P1 comes, then P2 comes, and then P3 comes, and these processes are served in the first come first served order, then we first of all we need to prepare the Gantt chart so that we can observe the uh, process execution time or the waiting time of each process. As we can see here, first of all, process P1 comes at time 0. We consider here that all the processes comes at time 0, but first of all, the CPU is allocated to the process P1. As we know here, as we can see here, that the burst time of process P1 is 24 units. So P2 has to wait for 24 units of time to execute. Right? P1 comes and the CPU is allocated to the P1. But in the case of P2, P2 has to wait for 24 units of time. And as we can see here that the burst time of P2 is 3 units. Right? So it executes for 24 to 27 units of time. So notice here that process P3 has to wait for 27 units of time, and the total time in which all the processes are executed, or the completion of execution of all the processes, is 30 units of time. Right? Now if we calculate the average waiting time, so the waiting time for P1 is what? 0. The P1 comes and the CPU is allocated to P1, so the waiting time is 0. But for process P2, the waiting time is 24 units of time. Here we have taken the unit in millisecond. Okay, so the waiting time for P2 is 24 milliseconds. Similarly, the waiting time for P3 is 27 milliseconds. Now if we calculate the average waiting time, so for average waiting time we have the formula, the waiting time of P1 plus P2 plus P3 divided by 3. So the calculated waiting time is 17 milliseconds when these processes come in the order of P1, P2 and P3. Now if we change the order of these processes, then what will happen? Suppose the order is changed, and first of all process P2 comes, then P3 comes, and finally P1 comes. So as we can see here that the waiting time for P1 is 6 milliseconds, right? We can notice here from the Gantt chart, P1 comes at this 6 millisecond. After 6 millisecond, the CPU is allotted to the P1. The waiting time for P2 is 0 millisecond, means the process P2 comes and the CPU is allocated to the process P2. And the waiting time for P3 is 3 milliseconds. Now if we calculate the average waiting time using the same formula, then we see that the average waiting time for this is 3 milliseconds only, and in the previous case we had 17 milliseconds. Means if we change the order of processes, the order of arrival of processes, then average waiting time, there is a huge difference between the average waiting time if we change the order of arrival. Okay, next, the first come first serve scheduling algorithm is non-preemptive. Non-preemptive means if some process is being executed, that means only that particular process will execute. There will be no interference of any other process, right? So this concept is called non-preemption, right? Means once the CPU has been allocated to a process, that process keeps the CPU until it releases the CPU, either by terminating or by requesting the input-output operation. Okay, so this is the concept of non-preemption, and the first come first serve scheduling algorithm is non-preemptive. The first come first serve algorithm is this particularly troublesome or cumbersome for the time sharing system. Means FCFS is not useful in the case of time sharing systems, where it is important that each user gets a share of the CPU at regular time interval. In time sharing system, what happens is that the time of CPU is shared among all other processes. So it is not possible. First come first serve scheduling concept is not possible for time sharing systems. So it would be disastrous to allow one process to keep the CPU for an extended period. Means if the burst time of some particular process is very large, then what will happen? Other processes will be waiting for a long. And this kind of situation is called starvation. When some process is waiting for a long, right? So thanks for now. In the next lecture, we will take an example on first come first serve algorithm. Thank you so much.